Okay, Trig section 1.3, number 39. If a car runs over a nail at 55 miles per hour and the nail is lodged in the tire tread 13 inches from the center of the wheel, so is that a radius? Right?
Yes.
So radius is, if the nail is lodged 13 inches from the center of the wheel, so that's the radius. Then what is the angular velocity of the nail in radians per hour? Okay. So let's see. I like to use conversion factors for these. So I need to change miles to radians. So first of all, and our radius is in inches, so I probably should start by changing miles to inches, shouldn't I? So if I want to get rid of miles, miles is right now on top, so I'd have to put that on the bottom. So 1 mile is equal to 5280 feet, correct? And then 1 foot is equal to 12 inches. And then we want radians. Okay, why do I get so confused on these? I don't know why. Something to do with circumference here. Where does that go? So, do we want... There's 2 pi radians in 1 circumference, right? Which is 2 pi r inches, right? I'm probably doing this a weird way. And so r is what measurement? 13 inches. And so then we get rid of our miles, we get rid of our feet, we get rid of our inches. We should have radians per hour after we multiply 55 times 5280 times 12 divided by 13. So let's try that. 55 times 5280 times 12 divided by 13, which is 268061 radians per hour. And the answer gives their answer to the nearest tenth. I just didn't put that part down. My answer does match their answer, so whatever I did turned out good. What's your question?
What's it divided by 18?
There's not divided by 18, it's 13 because that's the radius.
Oh, sorry.
Divided by 13, which is the radius. I think we could just use formulas we learned last time instead, if you'd rather use those formulas. So what we're trying to find here is angular velocity. Oh, and we learned this little formula that linear velocity is equal to r times angular velocity, correct? So that's the formula for linear velocity that we learned last time. So we can switch this formula around by dividing by r, can't we? Or angular would be omega equals velocity divided by r. So let's look at what we just did here. We took a linear velocity. We changed that linear velocity from miles per hour to inches per hour so it matched the inches. And then we simply divided by r, didn't we? So it's linear velocity divided by radius r gives you angular velocity. So I used conversion factors to do the same thing that this little formula we learned yesterday does. So whichever way is easiest for you to understand. If it's easier to just use the formula and memorize this formula and realize you can switch it to this, then so be it. Do you see how section 1-3 can end up being a little bit tricky for you later when we've done it at the very beginning and we end up having to be tested on it at the final at the end of the year and we've completely forgotten how to do it? Yeah. So this will be an area that we're going to want to for sure review in May before the final. So, okay. Are we good? Is no comment good?